Hi everyone, I'm going to try my best to quickly go over all these chemistry problems and explain how you get to that answer. So here we have a nuclear equation and it's asking us to find the missing element, right? So we can see that in the product side, we have a beta particle being released. And the reason why I know it's a beta particle and not a positron is because a positron looks like this, where it has a +1 at the bottom. But this one has a -1. So since it's a beta particle, right, I'm going to add the atomic number by 1. So instead of subtracting by 1, which you see here, I'm going to add by 1. So my new atomic number is going to be 16. And my mass is going to stay the same. So it's going to be 32. So now I just look at the periodic table elements and I look for which element has the atomic number of 16, and it's going to be sulfur. Next one, which list of nuclear emissions is arranged in order from greatest penetrating power to the least power. So it's just asking for energy. And energy also equates to frequency. But if you know this already, gamma has the highest frequency while beta and alpha are not as strong. But the reason why gamma has the greatest penetrating power is because it's pure energy being released. So it's just straight energy, it's just light. That's why it's gonna have the greatest penetrating power. And I guess a way you can remember this is like alpha, right? First letter of the alphabet, then B, second letter. So A is gonna go at the end when it comes to least power, but then if it was asking you for least to greatest, then it'd be A, B, alpha, beta, then gamma, because gamma is always gonna be the greatest penetrating power. So then here we have another reaction, and it's asking whether it's a fission or a fusion reaction. Well, we see here that a neutron, right, it's bombarding uranium and it's causing it to break down. So this neutron is colliding into an unstable and heavy nucleus, causing it to split into these two smaller nuclei right here. So all you can remember this is that fission is from heavy to light or large to small, and fusion is from light or small to heavy and large. But what they both have in common is that they release a lot of energy. Now we have the combined gas law. So the combined gas law, you just need to know the formula, which is already given to you on the reference table. So the combined gas law is P1 V1 T1 equals P2 V2 T2. So P1 V1 T1, these are our initial values, and then P2 V2 T2, those are our after. So it's saying show a numerical setup for calculating the volume of the gas in cylinder B at STP. So it's asking for cylinder B, so we can ignore cylinder A. And here we already have our initial values. So our volume, our pressure, and our temperature. So our pressure is 1.5, our volume is 2, and our temperature is 350. Now it's saying for STP and volume. So we don't know where our volume is, but it's specifically talking about STP, and we find STP on the same page of our reference table. So right below the mathematical relationships table, it says standard temperature and pressure conditions are 273.15 Kelvin and 1 atm, or pressure. So we have our pressure as 1 atm and our temperature as 273.15. So we just plug that in because we're solving for volume, so that's why we don't have that. So pressure is 1. We don't know what the volume is because that's what we're solving for. Then temperature is 273.15. And that would be our numerical setup. As you see here, 1.5 times 2 over 350. Then 1 times our missing volume over 273.15. Then you just cross multiply it and you solve for x. And you're going to get 2.3 liters. Now here we have which description of a graph represents the relationship between pressure and volume for an ideal gas sample when the temperature is constant. So if we rewrite our equation for combined gas laws, we have P1 V1 T1. So a trick that I was taught is that if they're next to each other, they're going to have an inverse relationship, but if they're on top of each other, they're going to have a direct relationship. So it's asking for pressure and volume. So as we increase the volume, pressure is going to decrease. So it's going to look like this. Now the reason being is, let's say, because if we have a container, right, if it starts off small and we have our particles here, right, they don't have much space to move in. But if we increase the volume of that container, these particles are going to have more space to move in, relieving that stress. So it's going to slope downwards. It's going to have an inverse relationship. And we can see that again, because pressure and volume, you see these are next to each other, so they're going to be inverse. Then we have all of this, right? You see all of this? You don't really have to read any of this. All that matters is this information here. So a technician at a treatment facility analyzes 400 gram sample of contaminated water and determines it contains 0.012 grams of this. What is the concentration of cadmium nitrate in parts per million? So we're going to use this formula here, ppm. So we know that the mass of the solute is 0.012 grams because we already know that the solution is going to be the contaminated water because that's a solvent. And the grams of cadmium is our solute because that's what's in the water. That's what's in the solution. So we're just going to make this proportion right here. Our solute over solution times 1 million, we're going to get 30 ppm. Then we have the technician prepares a separated concentrated stock solution of sodium sulfide by dissolving 39.02 grams of sodium sulfide. Oh, actually, we did this problem. You know what? I'll just do it again. So it's asking to find the molarity. So the molarity equation is already in your reference table. So we have N equals MB. M is the molarity. But if we want to solve for specifically molarity, we need to isolate M. So we're going to divide by V on both sides, and we're going to get that M, or molarity, is equal to number of moles over the volume. So here we're only given grams and the gram formula mass. We're not given moles, so we have to convert the grams into moles. So you do that by taking the given mass, which is 39.02 grams, over the molar mass, also known as the gram formula mass, and convert it into moles. And you're going to get this many moles. And then you just input that value into this formula here, which was your moles over the volume, which was 2.5 liters. Now here we have the equation here, and it's asking us to identify which product will form a precipitate or an insoluble solid. So we're looking at the product side, and it's asking which one is going to be insoluble. Well, in our table of selected ions forming aqueous solutions, anything that's in that table is going to be soluble. If it's not in that table, it's going to be insoluble. So if we look at the table, Na is in the table because it's in the group 1 metals. So that's going to make this whole compound here soluble, meaning that CdOH, or cadmium nitrate, is going to be the insoluble solid. It's going to form the precipitate. Now we have here, what is the term of a solution that contains less dissolved solute than a solvent can hold? So we have saturated, unsaturated, and supersaturated. Supersaturated means that it has way past the maximum amount of dissolved solute. Saturated is that it's at its maximum, and unsaturated is that it has less. So as long as you know that definition, this question is easy to answer, which is going to be unsaturated. Because unsaturated, you can think of it as a minimum. Now, colligative properties. So it's saying what occurs when NaCl is added to water. So salt, which is a solute, is going to be added into water, which is our solvent. And whenever we add salt into a solvent, if you already know this, the boiling point is going to increase and the freezing point is going to decrease. So one example called freezing point depression. So whenever it's going to snow, we're going to add salt to the ground because we don't want ice to form. And the whole purpose is that salt is going to decrease the freezing point of the water. So it's going to actually prevent it from freezing so quickly or so easily. Therefore, what the salt is doing is that it's lowering the freezing temperature. It's going to cause the freezing temperature to be even lower in order for ice to actually form. So what's happening is that the solute molecules is disrupting the solvent's ability to bond and arrange into a solid crystal lattice structure. So it's just preventing the ability for the ice to form. So therefore, the freezing point is going to decrease because it's going to need to be colder in order for that ice to form. Now, last but not least, the longest wavelength, lowest frequency electromagnetic waves are radios and microwave. These rays have little energy that can't pass through many materials. This makes them useful for certain purposes like cell phones. explains in terms of ionizing or non-ionizing radiation how radio waves do not have damaging effects on living tissues. Well, if you look at the electromagnetic spectrum, radio waves actually have the lowest frequency and also the highest wavelength. So if it's going to kind of like this, right? The wavelength is going to be quite long, right? But it's also not going to be moving as frequently. And because of this, because it has a low frequency, it's going to have a lower energy, making it non-ionizing. And what it means to be non-ionizing is that radio waves, they don't have enough energy to cause an atom to lose an electron.